everyone, welcome to Insights by Rish. In today's video, we are going to implement a project of detecting fake news and the real news. So we have a dataset from Kaggle and we have to detect whether the news is true or false. And for that, we have two files here, the fake CSV and true CSV. After downloading this, we have 4 columns here which consist of title, text, subject and date, but we just require the column text here and nothing else. So the ultimate goal is to predict that whatever news we are going to supply to our model, the model should detect whether the news is fake or not. So this project falls into natural language processing NLP domain. So let us start implementing the project now. First we'll import pandas. Then we'll import our dataset. So we'll import it in fake_df. We need to import 2 different files here. First is the fake CSV. So I will say pd.read CSV, and here I will provide the path on which my dataset is stored. Let's run this and let us try to visualize our dataset first, and let us also check the shape. So we have in total 23,481 rows into this particular dataset and 4 columns. We don't require the other 3 columns. We'll just do data cleaning in the later part. First we'll also load the true CSV here. So we'll name it as true_df and we will say pd.read CSV. Here I will provide the path. Just let me change it to true. Let's run that and let us again try to display the true data frame. And then we will also check the shape of our true data frame. So this true data frame consists of 21,417 rows. Now next thing that we want to do is we want to delete the unwanted columns from both the data set. So for that we'll say here deleting unwanted columns, and here we'll just say df fake df dot drop, and the columns that we don't require here are, the first is title, then is subject, then date. These are the 3 columns that we don't require, and I will say in place is equal to true in order to make the changes permanent. The same thing we also need to repeat on the true data frame. So we'll do it in this particular cell itself. We'll just change the name from fake data frame to true data frame, and the column remains same. So let's run this and let us try to check the columns from fake data frame and true data frame. So now we just have text column into the fake data frame and also I think in true data frame. Fine. Now the next thing that we want to do is we want to check for null values. So we'll say checking for null values. Now the 2 data sets are still individually different, so we need to check for the null values differently. So we'll say fake data frame dot isInA dot sum, and we have no null values into the fake data frame. We'll also repeat the same thing for true data frame, and again we don't have any null values in. Now we want to perform a very important step here. If you take a look at your fake data frame and true data frame, you might notice one thing. Let me also display the true data frame. You might notice one thing, we don't have labels here, and that is because they already mentioned that a particular CSV file only consists of fake news and true news. They aren't mixed with each other, and hence we need to explicitly assign the labels to them. We will assign the label 0 to true data frame, and we will assign the label 1 to all the fake data frame newses. So which means if the output is 0, that will be a true news, and if the output is 1, then that will be a fake news. So to do so, what we will do, we'll say fake data frame, and here we will add a new column saying let us name it as label, and here we will say value 1. And the same thing we will perform on true data frame as well. Just we will change the value to 0. So true data frame and the value will be 0. So now we have label to our fake data frame, and we might have label to our true data frame as well. So now we have the label. The next thing that we want to perform is now both the data sets are clean, both the data set have same number of columns and even the same column names. So now we want to concatenate both the data frames, but there's one issue here. Now both the data frame consist of large number of rows. That is, the first data set consists of around 23,000 and the second data set consists of around 21,000. Now if you try to perform all the natural language processing computation of text pre-processing using that many rows, it will take a lot of time. So I am just going to use a portion of data here. If you want, if you have a lot of time, you can perform it on the entire data set using the same techniques or all the same steps. The steps will remain same, but just I am reducing the number of rows. So here what we will do, we will say that in a fake data frame, this is a new data frame, we are going to say we want to reduce the number of rows. So we will say fake data frame dot location. I will just include first 5,000 rows. So that is, we are going to create a new data set of 10,000 rows. 10,000s are still more, but we can't reduce it more as we will be losing a lot of information there. So we'll just create a new data set of 10,000 rows, which will include 5,000 rows for fake news and 5,000 rows for true news, which means our data set will be balanced. And the same thing I am going to repeat for true data frame as well. Instead of data frame, we'll just say fake because we already have a data frame named by fake_df. So we'll say true here, and here true data frame. Let's run that and let us try to check the shape of fake and true here. Now as you can see, now the fake consists of 5,000 rows and the true data frame consists of 5,000 rows. So now we are going to create a new data frame out of this, which we will name it as a df, and we will say pd.concat. Here I will provide the name of data frames that we want to concatenate, which is a fake and true. And we also need to provide the access here, that is on basis on what basis you are concatenating. So here we are concatenating on the basis of rows. So I will say access is equal to 0. Let's run that and let us try to display our new data frame that we just now created, and we will also check the shape. So this particular data set consists of 10,000 rows and 2 columns. Now the next thing that we want to perform here is we will start with text pre-processing. So let me name it here text pre-processing. So for that, either you can go ahead with NLTK library, that is your natural language toolkit, or you can go ahead with Spacy library. I am particularly going to use the Spacy library because that's more efficient than NLTK. And also there's one advantage of using Spacy, that you don't need to explicitly tokenize the sentences. It will do it for you. So I will import Spacy here, and I will also create a Spacy pipeline here. So I will store that Spacy pipeline in NLP variable, and I will say spacy.load. I will load the English module here, which is en core web small. Let's run this. Now the next thing that we want to do is we want to perform various text pre-processing techniques on this text dataset and not on the label. Now the thing that we are supposed to do here, firstly we need to do lemmatization on the text column, that is convert all the words to their root words, and second we need to remove the stop words and the punctuations. So first we will start with lemmatization, and for lemmatization we will write a function here which is a def lemmatization. Here we will pass a text. This text will basically be every individual row from the text column. And here we will say doc is equal to NLP text. Here we are simply passing the every individual row that we have extracted from the text column to the Spacy pipeline. Now here we will write a list comprehension syntax. So we will say lemma list. Either you can perform stemming on the text column or lemmatization. You don't require both, but lemmatization is more efficient as compared to stemming, because stemming consists of lot of errors. Hence I have preferred lemmatization here. So we'll say word.lemma for word in doc, and we are going to join it because we want all the results in one single row. So I will just say dot join lemma list. Let's run that. And then we are going to apply this function onto our text column, and we are going to store the transform data into a new column named as lemma. So we'll create a new column here, lemma, and here we will say df text. Onto this column we are going to apply our function. So apply lemmatization. Let's run this. Now after that, let us again visualize our data frame. As you can see, the new column lemma is added and the words are converted to their base form. So if you want to check for an example here, that if you want to confirm that whether the conversion really happened or not, you can just spot an example, and here you can see in the last row the used is converted to use. So the converting from word to its root word has happened correctly. Now the next thing that we want to do here, we want to remove the stop words from the lemma column and also the punctuations if there are any. So to do so, we will again write a function here. The stop words basically are the words that don't make any meaning individually, but only when they are in a group, like the words is, the, then, and they don't provide any context individually. So we want to remove such words. So we'll write an function for that. Remove stop words. Here we'll again receive a text, which will be every individual row from lemma column. And here we will say again doc is equal to NLP text. Then we will again write a list comprehension code snippet here, no stop words. And here we will say word dot text for word in doc, if not word dot is stop, and not word dot is punct. What I basically mean here is I want to involve every text of, that is every word from the lemma column, except for the word shouldn't be a stop word or a punctuation. And then I'm again going to join that. So dot join, no stop words. Now we are going to apply this function on the lemma column, and we are going to store that results into a new column. So let us name that new column as final, because that will be our final column. We won't require any more further pre-processing. This is the last text pre-processing step that we have in our project. So we'll store the new column name as final, and then we will provide the column lemma onto which we are going to apply our function. So apply remove stop words. Let's run that. Now let us try to display the dataset now. As you can see, now we have our final column where we have removed all the stop words. If you want to spot some differences, you can check that in the first row, initially you had the just there, but now you don't have that. Similarly, you had all, but now you don't have. So your function have removed all the stop words from the final column. Now we don't require this text and lemma column, so we'll just drop them. What is important to us is just the final column and the label column. Or else, rather than dropping them, what we will do, we will create the new data frame which will consist of a final column and a variable which will hold our target feature. We'll just say dividing the data set. The capital X will be of type data frame, which will consist of our input column, that is final. So we will say final, and Y will hold our target feature, which is label. Let's run that, and let us just try to display the input data frame. This is our input data frame. Now we are done with all the text pre-processing that we want to do. Next thing, we will start training our model. Now to train our model, we are going to use the random forest classifier algorithm here, and we also require TF-IDF vectorizer here. TF-IDF vectorizer is basically the main component of this entire model, and we are going to pass our algorithm of random forest classifier and the TF-IDF vectorizer in a pipeline, in a machine learning pipeline. So we will first import the algorithm from sklearn.ensemble. So we'll import the random forest classifier here. Then we require TF-IDF vectorizer. So from sklearn.featureextraction.text, we are going to import TF-IDF vectorizer here. And next we also require pipeline. So from sklearn dot pipeline, we are going to import pipeline. Now we will start building our classifier here. So we will say, now before doing this, we need to do one thing here. We need to divide our data set into the training set and the testing set. Basically we want training set to train our model and the testing set to evaluate our model upon. So for that we require the train test split here. So from sklearn.model selection, we are going to import train test split, and here I will say xtrain, xtest, ytrain and ytest. Then here I will say train test split. Here I will pass my input data frame, which is x, and my target feature, which is stored in y. Then I will say test size as 0.2, which means 80% data in the training set and 20% in the testing set. And then I will provide an attribute random state is equal to 42. Let's run that and let us check how many rows are now included in the training set and the testing set. So initially we had 10,000 rows in our data set. So out of 10,000 rows, 8,000 rows are now in the training set and 2,000 in the testing set. So here now we will build our classifier. We will say a classifier is equal to, we will create a pipeline here, into which we are going to pass first our TF-IDF vectorizer here. So we'll write a name here, which is vectorizer TF-IDF. You can give any name here. And here I will pass TF-IDF with parenthesis. And the next thing that we want to pass here is our algorithm, which is random forest classifier. You can name it anything here. I will name it random forest, and here I am going to pass my random forest classifier with the attributes njobs is equal to 1 and random state is equal to 42. Then you just want to say here classifier dot fit, and here I will pass my training set, so xtrain and ytrain. There's some issue here, found input variables with inconsistent number of samples. Okay, this issue I think is basically, okay, the issue is basically that we don't require a data frame here. If you check the data type here, if you just say type of x and type of y, it will give the type of x as data frame and type of y as series. But here you don't require type of data frame, type of x as data frame. You require it to be series. So you will just remove one bracket here and let us again check. Now it is series. So this is what we wanted, and that's why the issue arises. Let us again perform all the things. Let us again train it. So it has completed its training. Let us check the accuracy here. So we will say classifier dot score, and we will evaluate it on our testing set. So xtest and ytest. The model is giving 99% of accuracy. So we are correctly detecting the fake news and the real news. If you want to use some more evaluation metrics here, we can go ahead with confusion matrix and classification report. So from sklearn.metrics, we will say import accuracy score, then the confusion matrix, and then the classification report. And for this, before that we need to do one thing. We need to store the predicted values into some variable. Let's say in pred variable we are going to do something like classifier dot predict, and here we are going to pass our testing variable xtest. Let us pass that and let us check what values our pred has stored. First 5 values, and which is it is saying that first news is true and all other are fake news. And let us check what the true labels are. So we will say the true labels are stored in ytest, and the first 5 values, as you can see, it's correctly predicting for the first 5 instances that first news is a true news while all 4 others are the fake ones. So now that we have stored our predicted values in the pred variable, to print the accuracy, the one way of printing the accuracy is this way. You can directly use the score method on the model that you have trained. Rather than that, you can also do something like this. You can just say accuracy score here, and you can pass your variable which stores true label, that is ytest, and your predicted wins. which is spread variable. Well, just multiply by 100, and you can see your model is giving you an accuracy of 99.7%. So let us do this thing that let us say print model accuracy. So we are getting an accuracy of 99%. Next thing is we will try to print the classification report here. We again need to pass our true labels and the predicted ones. So as you can see, the F1 score for both the classes, that is for the fake news and for the real news, is 100%. That is, this data set is purely balanced data set. If you find there is a drastic difference between your F1 score of both the categories, then you can understand that there is a highly imbalance in your data set. So next thing that we want to do here is we will try to print the classification report, and for that we will require C1 here. We will say import C1 as SNS, and we will build the confusion matrix here. We will store it in CF variable. We will say confusion matrix. We will pass the true labels and the predicted ones. We will also say normalize is equal to true, and then we will say SNS dot heat map. Here we will pass our CF variable. Then we will say N0 is equal to true, which means we want to display the values on the grid, and then CMap, that is the theme of your heat map. I want it to be crest, and let us try to display this. So this is your heat map, and let us label that. We will say SNS. Actually, we require here matplotlib as well to label our heat map. So we will say import matplotlib.pyplot as plt, and here we will say plt.xlabel. On x-axis you have all the predicted values, so we will label it as predicted, and on y-axis we have all the actual values, so we will label it as actual. And then we will also give a title here, so plt.title, which is confusion matrix for fake versus real news. And we will also try to increase this font, so I will just say something like this, plt.rcparams, and here I will say font dot size. I want my font size to be 14. Let's run that, and as you can see, this is your confusion matrix. On y-axis you have actual values, on x-axis you have predicted values. So basically on your diagonal, that is in your dark blue squares, you have 100% precision or 100% recall for every news. That is, even your model is correctly predicting the fake news, and even your model is correctly predicting the real news. So as you can see, this was the model, and we built our model with an accuracy of 99%, which is really very good. And that's it for the video. Thanks for watching.